In this video, we're going to use dimensional analysis to convert units. So when we talk about unit conversion, that means like taking feet to inches, which isn't the kind that we're going to be doing here. We're going to be doing more complicated ones like cubic feet to gallons. So for example, convert 22,500 cubic feet to gallons. When you do this, you'll need a conversion factor. So our conversion factor here is that 1 cubic foot is about 7.48 gallons. So you'll need to know how the two are related to each other in some way or another in order to do this. Now, before we go on, I want you to note that instead of writing out the words cubic feet, I'm going to abbreviate that as FT to the third power, or feet to the third, feet cubed. Alright, so what I'm going to do is write out all the math that needs to happen, and then I'll explain the setup and the dimensional analysis part. Alright, so this is how you would set it up. And before I talk through each piece, first I want to emphasize that when I wrote this out, I included the units in what I was writing. That's going to be very important to the dimensional analysis part of it. That's what is going to make it basically dimensional analysis, is that we are including the units in the problem. Okay, now let's look at this first fraction here. The first fraction will always be what you start with over 1. So what I mean by what you start with is we are starting with cubic feet and we are converting them to gallons. So the first fraction is always what we're starting with. The second fraction is a ratio of the units you have to the units you are converting to. In other words, the second fraction is going to be your conversion factor, the thing that relates the two, expressed as a fraction. Now, what goes on top and what goes on bottom varies. So here I put gallons on top and cubic feet on bottom. Sometimes that'll be switched around. That's based on the units you are going to should be on top. The units you are starting with should be on bottom. So remember, in this problem, we're starting with 22,500 cubic feet. That gives us our first fraction, and the units for that are there. That's what determines what goes on the bottom over here. In other words, we want the units we're starting with on the top for our first fraction and on the bottom for our second fraction. This is so that mathematically they'll end up canceling out, because anything multiplied the same on top of a fraction and bottom of a fraction cancel. Okay, the last thing I would like to emphasize is with these unit conversions, we're always multiplying these two fractions that we set up. It's always going to be multiplying when you're converting between units. So again, going over all that, the first fraction is what you're starting with over 1, and then we're going to multiply that times your unit conversion factor, where we put the number we're going to on top, or the types of units we're going to on top, and the number associated with that, and the units we're starting with on bottom. So now that we have all that, I'm going to clear out all of my writing so we can actually work the problem. In your notes, you might just reconsider rewriting the green separate, and then we'll actually do the work so you can see how it works. Alright, here we are. So, like I was saying, when you're multiplying two fractions, anything that's the same top and bottom will cancel. So here, our feet cubes will cancel out. Now that leaves us so we only have ones in our denominators, which means those are going to divide out. So what we can do now is take our 22,500 times the 7.48, and we also still have our gallons because they weren't able to cancel out with anything. Doing the math on that, it gives us 168,300. So 22,500 cubic feet is equivalent to 168,300 gallons. So that's how it works. The idea that it's dimensional analysis, what makes this dimensional analysis is the units. Sometimes you could think of this as like unit analysis. The units are what we're considering our dimension. And so we're doing the math. We're including the units in the math, so when they can cancel out, they cancel out. And that's why we convert to gallons, because setting it up this way cancels the cubic feet and leaves us with gallons. Let's look at another example. Alright, so here's our example. An aquarium has a volume of 36,000 cubic centimeters. How many liters of water does the aquarium hold? And we need to know that 1,000 cubic centimeters equals 1 liter. Okay, let's go ahead and set this up. The first fraction is what we're starting with. So we're starting with the 36,000 cubic centimeters. And we're going to liters. So we're going to take our 36,000 and then centimeters cubed. We write like that. And then that's going to be over 1. We're going to multiply that times our conversion factor, the relationship between the centimeters and the liters. And we always want to put the one we're going to on top. So in this case it's liters, so 1 liter on top and 1,000 centimeters cubed on bottom. Sometimes people fall into the trap of thinking that they always put the one that's a 1 on bottom, but that's not true. The one that goes on top is what we're going to. The units we start with always goes on bottom. Okay. Now, because we set it up right, these centimeters, that should be to the third. Let me correct that. Now I can cancel it with centimeters to the third here. Okay, and now when I do the math, this is a little different than the first example. I have 36,000 times 1 liter on the top, and that's over 1,000. No units on the bottom because those units canceled. So the 36,000 times 1 is just 36,000. So we have 36,000 liters on top. And then on bottom, we have the 1,000. So to get this down, we need to go ahead and divide. The numerator divided by the denominator. And that's going to give us 36 liters. So now comparing example 1 to example 2, one of the things that the dimensional analysis does is it helps us cancel out the units, but it's the real beauty of this setup is it's going to tell us in order to convert, do I need to multiply or do I need to divide? And that all comes down to how you set it up so that your units cancel. Once you set it up so your units cancel, then it will tell you whether or not you're going to end up needing to multiply or divide. And it's different in different cases. Okay, that's the idea of using dimensional analysis for unit conversion. Go ahead and give some of these a try and see how you fare.